In this lesson, we are going to learn how to solve trig equations. Let's begin with a simple example. Please note, the x represents an angle in this equation. And because of the cyclical nature of trig functions, there are infinitely many possible angles that will satisfy this equation. Step 1 is to always do the following on your calculator. Please note, we use the sine -1 key, not the sine key. To get this, you need to use the second F or Shift key on your calculator. But before doing this, you always need to make sure that your calculator is in degree mode when doing trigonometry. If it is, then correct to 1 decimal place, you should get the following answer. We are now ready to write down the solution. The solution is the angle you have just found plus k 360 degrees, or 180 degrees minus this angle plus k 360 degrees, where k is an element of the integers. We add k 360 degrees because sine is a function that repeats itself every 360 degrees. We call this the general solution. It gives all the possible solutions and will work for any equation with sine in it. Let's see what to do to get the general solution for cos x equals 0,6. Again, we begin by doing the following on the calculator. Don't forget to make sure that your calculator is in degree mode. Correct to 1 decimal place. This gives the following answer. The general solution for cos is plus minus the angle we have just found, plus k 360 degrees. Again, we add k 360 degrees because cos is also a function that repeats itself every 360 degrees. Let's see how to get the general solution for tan x equals 0,6. Step 1 again is to do the following on the calculator. Correct to the nearest degree. This gives the following answer. To get all the possible solutions for tan, we simply add k 180 degrees to the angle we have just found. This time we only add k 180 degrees because tan is a function that repeats itself every 180 degrees. Let's recap. When asked to solve trig equations, we always begin with the following calculator sequence to get an angle. We then use this angle to write down the general solution. For sine, we need to write it down twice, first on its own, then we subtract it from 180 degrees. For cos, we write it down only once with the plus minus in front. And for tan, we again only write it once. And don't forget with tan, we only add k 180 degrees. Let's go on to solve some equations. Here is the first example. We are asked to find the general solution for cos x equals minus 0,85. We begin with step 1, which is to do the following calculation. Correct to 1 decimal place. This gives an angle which we can use to write down the general solution. For cos, it is plus minus this angle plus k 360 degrees, where k is an element of the integers. This completes the question. Here is the next question. We are asked to find the general solution for tan x equals minus 3. Step 1 is always to do the following calculator work. Correct to 1 decimal place. This gives an angle of minus 71,6 degrees, which we can now use to write down the general solution. To do this, we write down the angle once and add k 180 degrees, where k is an element of the integers. This completes the question. In the next question, we are asked to find the general solution for 2 sine x plus 1 equals 0. However, in this example, the equation is not given in the correct form to solve immediately. We first need to rewrite it. Let's do it. First, we need to subtract 1 from both sides to get 2 sine x on its own on one side. Next, we divide both sides by 2. The equation is now in the correct form to solve. In other words, sine of some angle is on the left-hand side and a number on the right-hand side. Step 1, as always, is to do the following calculator work. This gives an angle of minus 30 degrees, which we can now use to write down the general solution. To do this, we need to write the angle twice, first on its own, and then we subtract it from 180 degrees. On the right-hand side, we can simplify further by adding 30 to 180 degrees. The final answer is therefore x equals minus 30 degrees plus k 360 degrees, or 210 degrees plus k 360 degrees. This completes the question. In the next question, we are asked to solve for x if 3 tan x plus 5 equals 1, and x lies in the interval 0 to 360 degrees. Again, we need to rewrite the equation in the correct form before attempting to solve it. To do this, we begin by subtracting 5 from both sides. And then we divide both sides by 3. The equation is now in the correct form to solve. Step 1 is to do the following on the calculator. Please note how I use brackets in this step. Correct to one decimal place, the angle we are looking for is minus 53,1 degrees. The general solution to this equation is therefore x equals minus 53,1 degrees plus k 180 degrees, where k is an element of the integers. Let's now use it to find all the valid solutions that lie in the interval 0 to 360 degrees. If we let k equal the integer 1, we get the following angle, which does lie in the interval 0 to 360 degrees. This is our first valid solution. If we let k equal the next integer 2, we get another angle that lies in the interval. I have not tried k equals 0 or 3, because then we will get angles that lie outside the interval. In other words, there are only 2 valid solutions for this equation in the interval 0 to 360 degrees. Here is the next question. We are asked to solve for x if cos 2x equals 0,7, and x lies in the interval 0 to 180 degrees. The equation has been given in a form that can be solved immediately. In other words, cos of some angle equal to some number. We can therefore go straight to this important first step. Correct to one decimal place, this gives an angle of 45,6 degrees. We then use this angle to write down the general solution for cos, which is plus minus the angle plus k 360 degrees. But please take careful note. The angle we need to write down here is 2x, not x. This is important to remember. And then we need to divide both sides by 2, because we are asked to solve for x, not 2x. Please note I also divide k 360 degrees by 2. We are now ready to use this general solution to find all the angles that lie in the interval 0 to 180 degrees. If we let k equal 0, we get the following 2 possible solutions. The negative angle is not a valid solution because it lies outside the interval 0 to 180 degrees. The other angle is a valid solution because it lies inside the interval. If we let k equal 1, we again get 2 possible solutions. The first one is not valid because it lies outside the interval, but the second one is valid. This equation has therefore 2 valid solutions in the interval 0 to 180 degrees. This completes the question. Let's do one more example together. Here we are asked to solve for x if 2 tan x minus 25 degrees equals 1, and x lies in the interval minus 360 to plus 360 degrees. Again, we need to begin by rewriting the equation to get it in the correct form. To do this, we need to divide both sides by 2. Next, we do the following on the calculator. Correct to one decimal place. This is the angle we need for our general solution. The general solution is therefore x minus 25 degrees equals 26,6 degrees plus k 180 degrees, where k is an element of the integers. Again, note it is very important that you write down the angle given in the original question in this step. We then solve for x by adding 25 degrees to both sides. Please note, k 180 degrees is not affected in this step. Let's now use this general solution to find all the angles that lie in the interval minus 360 to plus 360 degrees. This time we will need to begin with k equals minus 2 to get the first valid solution, and then k equals minus 1, 0, and 1 to get the rest of the valid solutions. Please check that I'm correct. I hope you have found this lesson helpful. Good luck with the test.